everybody. Welcome back to Environmental Science Analysis with Dr. Lisa. In the previous video, we had downloaded some data from the EPA's water quality portal on perfluorinated compounds measured in all kinds of samples here in the United States. And so you can see here is the characteristic name. So for example, we have perfluorolauric acid, CFC 113, perfluorobutane sulfonate. I have a bunch of perfluorinated compounds here. And what we're going to do in this video is we're going to take this comma-separated value file that we've downloaded from the internet, and we're going to turn it into a database. So first thing I'm going to do, I opened this directly from the download file, so I want to save this, put it in a better place. I'm going to save it to where I save everything for this particular class, and maybe I'll call it perfluoro from Storette. And I always like to put the date on things, so today is July 27th, 2020, in the middle of COVID summer. I'm going to keep it as a comma-separated value file, save it there. And then I can go to Microsoft Access, which takes a moment to load. So here's Microsoft Access, and this is the way it looks when you first open it, and I'm going to make a blank database. You know, these are some of the recent databases that I've looked at. I'm going to make a blank database, and then it says, what do you want to call it? Perfluorocompounds, PFAS, from Storette, and again, I like to put the date on here. Oops. 2020. Okay, create that. So this is just creating a completely blank, empty file with, you know, it's not even really a database at this point because it has nothing in it. So we go up here to external data, and we say we'd like to import data. So this is the export. I want to import over here, import from a new data source, from a file, and it's a text file. And so then I have to browse over and find my data. Generally speaking, when you are working with large databases, it's better to save them to your hard drive and not have them in the cloud. Right now, the file that I'm looking for, I actually saved on the cloud. This is the one I just saved. Okay, so when I actually make the database, I'll store it on my hard drive. You generally don't want to be accessing databases from the cloud just because it's slow, and if you have really big databases, it can just take forever. There are ways to get around that, but for your purposes, it's generally better to save it on your hard drive. So I'm going to keep the default here, which is import the source data into a new table in the current database. It is also possible that I could append the records onto an existing table. This is great if you're building a database and you keep getting new data and you want to keep adding it to your database. But I'm just going to import it into a new table. So I'll say OK. And it says it cannot open or write to the file because it's already opened exclusively by another user, and that's because I have it open here in Excel. So I'll close that. That would be good. Okay, let's go back and we'll repeat ourselves. From file, text file, data mining course, PFAS perfluoro from Storette. Okay. And then it shows you what your data looks like, and it's guessing here that the data is delimited. And indeed it is. You could also choose fixed width, but this is a delimited file, so I'll say next. And this is generally a comma delimited file, but if you look over here, it's good to scroll over and see. Look at how this is splitting this geoengineer's ink across two columns because there's a comma in there. One way to deal with that is to tell it that the text qualifier is. You can see there's a qualifier here that text is given the double quotation marks. So if I put that in there, if I select that as my text qualifier, it will no longer split at that comma there for Geoengineers Incorporated. So that's good. I'm going to just kind of walk through this, make sure it all looks good. And you can see, you know, there's some commas here, but again, it's not separating via those commas because there must have been some quotation marks protecting us there. Lab sample ID, oh, so much data, height measurement. I just want to go through here. Here's my result analytical method, and somewhere in here, I should have some results. Here we go. That's the detection limit. But generally this looks okay, right? And I'm not seeing the result. Here we go. Here's the result measured value, and you can see it's in the right column. It's in the correct column. I can scroll down. It's always showing up in the right place. So that makes me feel pretty good about how this is done. And then the other thing I definitely want to do, if I scroll back up to the top, the first row is my header names. And so I'm going to click this box that says first row contains field names. And we could go through and it will identify each column and give it a field name and everything. And you can choose not to import certain fields if you want to, but I always just keep the defaults and just say finish. So it's going to take that comma separated value file now and turn it into a lovely, and I never bother saving my import sets. I probably should, but I never do. So typically when you import, here's the file that you just imported, and then there's always this thing called import errors. And you can see it had to truncate a field here. But it doesn't seem like this is anything big. I'm not too worried about it. So here's my actual data. And maybe now what I would like to do is do a crosstab query. So I could create I could use my query wizard to make a crosstab query. And this is the data I'm going to select from, per fluoro from Storette. And maybe I want my, let's see, what do I want? My activity identifier. So this is always the tough part, right? Deciding which, you want some sort of, sometimes it's important to look back at your data and think about, okay, what do I want to be my sample ID? Maybe I want this activity identifier because it is, well, no, it's not unique. The sample identifier is the same for a lot of different things. So maybe that's not what I want. I need to think a little bit about which of these columns I want to use as my sample identifier, project identifier, activity start date, activity type. Okay, maybe I'm going to use my activity identifier. Let's see how that works. Crosstab query, that's the data I want to use, and I'm going to use my activity identifier. Right, this thing, activity identifier, move it over here to my selected fields. And then it says I can select up to 3 fields. So maybe I'll do my start date and my start time. And I only get 3. You can add more than 3 later when you edit all of this. But you only get 3 through the wizard because the wizard has limited functionality. So which fields values do you want to be the column headings? I want the characteristic name to be my column heading. And then what number do you want calculated for each column and row intersection? I'd like to see the result. So here's the result measured value. You get a choice. You can count how many of these results there are. You can use the first, the last, the max, or the min. I like to start with counting, and I'm not going to include my row sums. And then if I hit finish, frequently what will happen, okay, so here's my query. You can see it's opened up here, and that's the name of it there. And these are all the different chemicals. I could tab through them all. And some of them actually give a value of 0 or 1. So one of the things I want to look for, and one of the reasons why I like to do the count feature, is I don't really want 2s here. I really don't want to have 2 samples that have the same, that both have the same activity identifier, but have 2 measurements of this particular chemical, which in this case is this perfluorooctane sulfonate. So that's disturbing to me. That means that if I used the first or the last or the min or the max, I'd get different numbers depending on which one I used. So I might want to, sorry, get rid of that. Might want to fart around a little bit here to see if I could minimize the number of times that a 2 shows up here. And then you also see there's a bunch of stuff here for which there is nothing. As I scroll down, here's some CFCs, you know, yeah, and here's some more samples where I have 2 measurements from the same sample. So maybe there's something different about this. Maybe this is, you know, sediment samples taking it at different depths or something. But whenever I'm ready and I feel comfortable that I have nothing but 1s here, I could go back to my design view. So I right-click on the tab here, go to design view, and then instead of saying I want to count, I could say, if I knew that I only have 1 value, I can say, just give me the first value. and it's the first value is the only value. So this isn't going to be exactly right because some of these had 2, but here we go. Here's all the data. So the data is showing up. And I could do other things. I could edit my design view here, and I could say that my characteristic name has to be like per fluoro, and then put a wildcard. So that way I won't get all that CFC stuff. And if I hit run, now I'm getting a smaller list of chemicals here. And so there's a bunch of things that I could do here. The other thing I could do, if I go back to my design view, so you notice this is the data I have to work with. And I could add in here, I don't know, all kinds of stuff here. Project identifier, group by, and you only get one column heading, but you can have as many row headings as you want. So I'm going to group this by row heading and run that bad boy. Now I have my project identifier. If I click the little down arrow here, it will tell me all the different unique values within this, if it's a reasonable number. If it's too many, it won't, but this is a reasonable number. So I'm going to unselect everything, and then maybe I'll just select, I happen to know that there's a lot of data here for this project. Okay, and of course it's not going to let me do that, but I can't do it here in terms of selecting, but I can design view and say project identifier has to be like, and I remember that it starts with Great Lakes because I did some work with this data, so GL. And then I could hit run. And now I have a much shorter number of samples. You can see now I've only got 169 samples. I had a lot more before. And much more of this data is actually relevant to me now. And so I could narrow down on the data that I actually need. And when I'm ready to maybe export this, it's real easy. You just click up here to select everything, Control C to copy, and then I could go back to Excel. Blank workbook here, and just Control V, and that will paste everything that I was just seeing in Access can then just get easily pasted into Excel. And then I could save this as an Excel file. I could save it as a comma-separated value file. I could do whatever I want with it. One thing that you will notice is missing here, and we were having a conversation about metadata. So one of the pieces of metadata that's missing here is a latitude and longitude where these samples were collected. The way that the water quality portal works, you're going to have to download that in a separate file, which is a bit of a pain in the ass, but that's the way they do it. So if I need a sample location in terms of latitude and longitude, I'd have to download that separately from the EPA's water quality portal and then try to mesh the two. And there's a couple ways to do that, which we can talk about. And we're going to, in our next video, we're going to talk about more complicated databases. So we've created a database here that essentially only has one table, right? It also has this import errors table, but we're not, that's not really important to us. We could delete that. We could just go over here and delete it. Okay, can't do it while it's open. Got to close it first. No, don't want to save changes. And we could just delete this. Yes, do you want to delete it? And we could also, if we close it first, we could delete this table 1 that doesn't have anything in it. It just disappears because it never had anything in it. So this is a very, very simple database. It's only got one table in it. But we're going to look at more complicated databases that have multiple tables, and you have to think about how are all these tables linked, and how can I get data from multiple tables into one query. So we'll talk about that in one of our upcoming videos.